Hi kids, let us go through the graphical representation of a linear polynomial. Let us find out 0 of the linear polynomial. We already learned what is 0 of the polynomial, no? So for what particular value of that variable, the value becomes 0. That is called the 0 of the polynomial. Suppose in general, if let us take if k is a 0 of a polynomial p of x is equal to ax plus b. We know that where a is not equal to 0, that is a condition, right? So it's a polynomial, it's a linear polynomial. So in this linear polynomial, if k is a 0, then how can we write this? We have to replace the variable x by k. So it will become p of k is equal to aK plus b. But we know that if k is a 0 of the polynomial, aK plus b will be 0. So it should be equal to, since k is the 0 of p of x, aK plus b should be equal to 0, because it is told that k is the 0 of the polynomial. When we apply particular value for the variable, the value gets us 0. That means this becomes 0. Then only which value we apply, that is known as the 0 of the polynomial. So now we are saying that k is the 0 of the polynomial. So when we applied k, aK plus b should be equal to 0. So from this we can find out the value of k. So k is equal to b goes to other side, it will become minus b and a get divided. So k is equal to minus b by a. So in general we can say that for any polynomial p of x is equal to x plus b, where a is not equal to 0, means a linear polynomial, 0 of the polynomial can be written as minus b by a. Okay, let us consider one question. 2y is equal to 2x plus 3. Okay, what is the 0 of the polynomial? 0 of the polynomial equal to, already we know the formula, minus b by a, right? So what is minus b? 3. So minus 3 is equal to minus 3 by 2. So in this way we can find out the 0 of linear polynomial without actual applying all values like 1, 2, 3, etc. Okay, now easily we can find out by using the formula. So to find out 0 of the polynomial, we can apply the formula k is equal to minus b by a. Okay, how can we find out the 0 of the polynomial? By using a graph, let us see now. Okay, the same question, y is equal to 2x plus 3. We know that the 0 of the polynomial is minus 3 by 2. Okay, through graphical representation of y is equal to 2x plus 3, let us check whether the 0 of the polynomial is same in both. Let us see now. Okay, now let us see how to find out the y coordinate by applying value for x. Okay, let us see. We can apply any value for x, but only one thing, whatever value we are giving, we should get a convenient value for y when we are writing on the number line. If we get too large values for y, it will be inconvenient. We can represent it, but it will be somewhat inconvenient for us. So always take convenient values only. So I have taken here minus 2, 0, 2. I can take either minus 1, 0, 1 or minus 3, 0, 3. Actually 2 values are enough. Okay, minus 3 and 3 you can take, minus 2 and 2, minus 1, anything. Now I have taken minus 2 and 2. Let us see what value we are going to get for y when we apply minus 2 here. First we will go with minus 2. X is equal to minus 2. That implies y is equal to 2 into minus 2 plus 3. So it's equal to 2 into minus 2 is minus 4 plus 3 equal to minus 1, right? So y value got minus 1. So the point is minus 2 comma minus 1. Okay, we got the x coordinate as minus 2 and the y coordinate as minus 1. Okay, now let us see for 0. When x is equal to, this is x is equal to minus 2. Next we are going for x is equal to 0. So what is y? Y is equal to 2 into 0 plus 3. Okay, that means 2 into 0, 0, 0 plus 3 is equal to, we got to 3. So, the points are 0, 3. This is the next pair. Okay, let us see what are we going to get when we apply 2. So, let us take x is equal to 2. So, y is equal to 2 into 2 plus 3. Whatever value we are taking for x, we have to give in the place of x. Because the question is 2x plus 3. No, the polynomial is 2x plus 3. So, in the place of x, we are applying the values. That's all. So, 2 2s are 4. 4 plus 3 is 7. So, we got 7. So, the pair is 2, 7. So, all the values of y minus 1, 3, 7, and that is very convenient for us. Either you can take a minus 1 and plus 1. That also convenient. Minus 3, 3 also convenient. No problem. Okay, you can take either of these sets. Okay, now I have taken minus 2 and 2. Of course, 0 also taken. Actually, 2 values are sufficient. Now, let us go into the graph. So, we got the ordered pairs as minus 2, minus 1, 0, 3 and 2, 7. So, we have to represent this one on the graph. We will see how we will get it. So, first pair is, so in the graph I have taken the scale on x-axis. This is the horizontal axis is known as the x-axis, right? This perpendicular axis is known as the y-axis. So, on the x-axis, I have taken 1 centimeter. Each one is 1 centimeter. Each box. So, 1 centimeter I have taken as 1 unit. 1, 2, 3, 4, 5, 6 I have written like that. And on the x-axis. Y-axis also same only. Y-axis also 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4. Like that I have written. That means 1 centimeter I have taken as 1 unit. Very convenient for drawing the graph, right? Okay. Now our first ordered pair is minus 2, minus 1. So we have to find out where is minus 2, minus 1. Okay. The x coordinate is minus 2. Where is minus 2? This is x-axis now. Where is minus 2? This is minus 2. So, minus 2 and the y coordinate is minus 1. Where is minus 1? This is minus 1. This is y-axis now. In this y-axis, where is minus 1? This is minus 1. So, you have to bring like this and bring like this. Both meet at this point. Right? So, this is the point which represents minus 2 and minus 1. X-axis or x-coordinate minus 2 and y coordinate minus 1. Okay, now let us go for the next point, 0, 3. This is 0, isn't 0, 3. 3 means y coordinate is 3. Where is 3? This is 3. So, this is the point which represents 0, 3. Okay, this is the point which represents minus 2, minus 1. Okay, now next 2, 7 means a pair 2, 7. X coordinate is 2 and y coordinate is 7. So 2, this is 7. Okay, this is 7. So bring like this, and where it is meeting with the line of 2. Okay, here it is meeting 7 and 2 is meeting at this point. Right, so this is the point 2, 7. Okay, already in earlier classes you have learned linear polynomial, you will get a straight line. Okay, that only we are getting now. The graph of a linear polynomial is straight line. See, now we have to connect these 3 points. Okay, only 2 points also you can draw you will get the line. Okay, for drawing a straight line, it's enough for 2 lines. Yes, 2 points. Okay, now let us connect it by using the straight line. You can extend. No, some children, what do? They exactly draw from here. Okay, it is a line. Line extends in both sides. No need to particularly start from here and particularly end at here. You can go on drawing like this. Both the ends you can extend because it is a line. Okay, you can extend like this. So this is the line. So here this line is going through the point 1.5 means this point. This we see that this line is crossing the x-axis or intersecting the x-axis at the point 1.5. This is 1.4 means this is the midpoint of 2 and 1, right? Means this is 1.5. We know that minus 1.5. You know that 1.5 means that is 3 by 2 only. When we are writing it as a rational number, we will get it as minus 3 by 2, right? It is minus 3 by 2. So, the value of x means where this graph, particular graph, this is a straight line graph. So, this graph, where it is crossing at minus 3 by 2. But already you have learned that, what did you learn? Minus 3 by 2 is a 0 of the polynomial. Right? So, this minus 3 by 2 only, this straight line is crossing at x-axis. It is crossing at y-axis at 0, 3 means at 3. But at x-axis where it is crossing, that is a 0 of the polynomial. So by both graphical method and by using the formula, we got minus 3 by 2. So what is this minus 3 by 2? Minus 3, you can write this point as minus 3 by 2, 0. Means y coordinate is 0 and x coordinate is minus 3 by 2. So what is the value of x? X is equal to minus 3 by 2. Okay, so what is the 0 of the polynomial? 0 of the polynomial is same thing. What is minus 3 by 2? 0 of the polynomial is equal to minus 3 by 2. So in this way we can find out by graphical representation, we can find out the 0 of the polynomial.